people. Sketching graphs of polynomial functions, huh? Yeah, that's, we're gonna do one more of these as a little warm-up, and then, we'll move on to something else here. Different types. We're still gonna be doing some sketching, but some different types of polynomial functions, people. All right, so here it is, page 20. I want to do number 5. And we're going to use this information here, the degree, the leading coefficient, the y-intercept, and the zeros. All right, to give this graph a sketch. All right, so I look at the x's here, right, to see the degree of this function. So it's an x times an x times a negative x times an x. So let's see, if we were to multiply that all out, x times negative x times x would get me a negative x to the 4th. Right, first term. So this would be a 4th degree polynomial function with a leading coefficient that is negative. All right, and like I said, you can put in, if you wanted to put in the actual number here, that would be a -1. All right, the y-intercept here, the y-intercept. Y-intercept, remember, we know the x is 0, right? The y-intercept is a point on the y-axis, right? And that has an x value of 0. So we're going to put in 0 for x, right? So 0 minus 1 multiplied by 0 plus 5 multiplied by 4 minus 0 multiplied by 0 plus 7 will get you the y value when x is 0, thereby being the y-intercept. -1 times 5, -5 times 4 is -20 times 7 is -140. The zeros now, are the x-intercepts, right? The x-intercepts here, where it crosses the x-axis. So basically, you can just set those factors equal to 0, right? X minus 1 equals 0. So, isolate for x. 1 is a root. X plus 5 is 0, right? So -5 is a root. 4 minus x equals 0. Be careful there, right? When you set that factor equal to 0. 4 is your root, not -4, people. Be careful there. And then x plus 7, right? Equals 0, right? So -7 is your root. All right, so let's see here. This is a degree 4 polynomial function with a negative leading coefficient. So that's going to be an M-shaped graph. All right, that'll be an M-shaped graph. All right, so let me do the roots. Plot those. We have 1, 4, -5, -7. And then we have a y-intercept of negative 140. All right, so here we go. We'll start sketching here, right? We'll work from left to right. Like I said, this is going to be an upside down W, right? So this is going to start down here, right, in quadrant 3. So here we go, right? It's going to go through, right, negative 7. And then, it's going to come back around here. Like I said, you didn't determine that. We don't know for sure where it's going to start making the turn to come back down. Like I said, unless we do more investigation. All right, which we're not going to do, right, with this. And then it's going to go, right, it's going to go through negative 5 and go to the next point here, which is negative 140, the y-intercept. And then it's going to come back up. All right, and go to the next point, which is 1, and then it's going to go through there, right? And then once again, it's going to come back around here. And like I said, that's your choice on how high you want it to go or how low in terms of when you want it to come back round, and then go through the last point there, which is 4. All right. And there you go. All right. Then we'll answer the end behavior questions. As x goes to infinity, what's happening to the function? And as x goes to negative infinity, what's happening to the y value? So the end behavior, right? We're looking at the ends here. This is x going to infinity here, right? But you're like, it's going down. Well, not for x, for y. For y, it's going down, right? Y is going to negative infinity. Over here, x is going to negative infinity. Right, x is approaching negative infinity here, and the y value is going to negative infinity as well. You're looking at the end behavior here, right, the ends. So both of these are going to negative infinity. All right. For negative and positive infinity for x, right, as it approaches. All right, very good here. Let's see now. Like I said, we're going to add on here, do a little something, some different versions of this now. And this is called multiplicity on the next page. Multiplicity. All right, multiplicity basically means here a repeated root. You have multiplicity in a function if a root is repeated. Okay, and there's two types of multiplicity. There's odd multiplicity and there's even multiplicity. Okay, now odd and even multiplicity, all right, you determine, all right, by how many times the root is repeated to designate it odd or even multiplicity. Not if it's an odd or an even number. All right, for example, right? Even multiplicity. So let me give you something like this. F of x will equal, x squared minus 10x plus 25. So I give you that function here, and we're gonna factor, right? Numbers that multiply to 25 and add up to -10 will be -5 and -5, right? Set those factors equal to 0, right? You get x equals 5, x equals 5. This is not odd multiplicity because 5 is an odd number. This is even multiplicity because the root 5 repeats 2 times, and 2 is an even number. So you determine multiplicity by how many times the root is repeated. If it's repeated twice, right, even multiplicity. If it's repeated 3 times, odd multiplicity. Repeated 4 times, even multiplicity. Repeated 5 times, odd multiplicity. Usually we do 2 and 3 here. Okay. Sometimes we'll see maybe 4, I forget, and maybe 5, but usually when a root is repeated here, it's either twice or 3 times. All right. So odd multiplicity would be, something like this. F of x equals x minus 2 raised to the power of 3. Right? Which, technically is x minus 2 times x minus 2 times x minus 2, right? And these roots, right, are all the same. X equals 2. Right? This is not, all right? This is not even multiplicity because 2 is an even number. This is odd multiplicity because this root is repeated 3 times. All right? This is twice repeated up here, which is why it's even, right? Multiplicity. It's repeated 3 times, odd multiplicity. Now, how does a graph look, all right, at those x values where there's a repeated root? Okay. So if you look at x squared minus 10x plus 25, let's see what happens here at x equals 5. So let's see if I can pull up this calculator here. I guess not. Let's see. Oh, do I have the calculator on here? I don't think I have it on this one. This is a different device. So maybe I'll do that on the next side here. Let me just check real quick. With the graphing calculator, I don't think I have it. All right, no big deal. So yeah, all right. So multiplicity, yeah, it starts. It starts when it's repeated twice, right? If it's just once, right, that's called a simple root. That's a simple root. That's what we were doing up here, right? Simple zeros or zeros that don't repeat just one time. That's a simple root. And graphically, right? Graphically, it goes straight through. When you have a simple root, right, that doesn't repeat, the graph goes right through that root. It's a little bit different, all right, and I'll show you this on the next video, when you have a repeated root in terms of what happens there at the root. If it's repeated even compared to repeated an odd number of times. It does not go straight through like it does with a simple root. All right, and I will get into that in the next video here. I'll see if I can get the calculator app here. All right, as this is a new device for me that I'm doing this on. So